Hi everyone, and welcome to Chapter 2 of this Blender Visual Effects course. I'm super excited about today since we're going to be talking about everything camera tracking. Now, I know we did a little bit of camera tracking in Chapter 1, however, that was a little bit of bare bones and a little bit simple. So in this specific chapter, we're going to be diving more into it, so by the end, you'll be able to camera track whatever footage that you want all inside of Blender. So of course, I have provided links for the footage that we're going to be using in a text document, so you can find that in the chapter folder. So do make sure you go download that. Now, before we get into the camera tracking, we need to actually convert those video files that we have downloaded into image sequences. Now, the biggest reason we want to do image sequences instead of video files is because image sequences are not tied down to a specific frame rate. Basically, each frame of a video file is going to be rendered as an individual image file, and then those played together as a sequence is basically going to give us the same result as a video. Now, I know when I'm working in between multiple different programs, programs like to use the video codec a little bit differently. So if we automatically convert it into an image sequence, it's basically going to allow us to communicate between the different programs. Basically eliminates a lot of the bugs that we have inside of Visual Effects. So let's go ahead and showcase how to do that inside of Blender. So we did a little bit in Chapter 1, but just a refresher, we're going to go to video editing, and then we're going to go ahead and add our movie. So here is the first clip that we're going to be working in. Let's go ahead and add that in. Now, the video editing workspace is actually great for this specific use case because it's automatically set our correct frame rate depending on what footage we actually have. So up here we have 29.97, which is the FPS of this specific footage. And then it's also set the correct color space. Now, you guys might get a little bit tired of me saying this, but if you remember in the color management, we have this view transform. Now, for anything 2D, such as videos, image sequences, image files, anything like that, the view transform is going to be standard. Now, when we're working with CGI or anything to actually render out from Blender, we're going to want to be in AGX, which is by default. So this video editing workspace automatically sets standard and the FPS, so that's really nice. Now, I'm going to have the frame kind of ranges I'm going to be using for each specific video. I'm only going to show you guys how to do this once. Of course, I'm going to be doing this by myself off camera on all of the other ones because I don't want to repeat myself, but it's all the same exact process. So just follow along with this for the other ones as well, using the frame numbers I have up here. So again, let's go ahead for the first one. I'm going to set a start of 1 and then a end of 200. And so those are down here. If you can see that, my webcam's kind of on the way. But for the first one, I'm just going to set that to be 200. So now that we have that, we can go ahead and go to the output properties. We need to render out where we want these images to actually be. So let's go open up a new kind of folder right there. Now, I do highly recommend that you guys make it its own folder since we're going to be rendering out as a ton of image files. So if you have it in its own folder, it's going to be separated from the rest. So of course down here we do need to name it, so name it whatever you want. I'm just going to name it name for mine. Very important, you do want to separate it by a underscore, and that's because it's actually going to put the frame number after this. And so I know for many different programs they kind of read in the frame range differently. If you put a underscore and then put the frame number at the very end, 90% of the programs I use will recognize that, and so that's just kind of the general rule of thumb that I use, is putting the name and then underscore at the very end. So let's go ahead and hit accept. Now I'm going to be rendering as a PNG sequence today. I know many people like OpenEXR is kind of the industry standard for stuff like that. Of course, we can go ahead and set the color to RGB since we don't have an alpha channel. Compression depth is 8th, and then the compression down here is going to be 15%. Now, PNG is actually a lossless format, and so you can set this percent to be anything that you want. I'm going to keep it on 15% because the higher you actually set that percentage, the lower the file size is going to be. However, the longer it's actually going to take to render, and so you can set that percentage accordingly there. So let's go ahead and render the animation just to render out all of the frames. Once those have all rendered out, you will have a folder that looks like this. You can see that all of our frames are actually named, and then we have the frame number at the very end, and they're all, each of the frames are rendered out as their own individual file. And so this is what we're going to be working with Visual Effects, and this will give us much more compatibility in between programs and eliminate a lot of the bugs inside of Blender. I know when I was using certain codecs of videos inside of Blender, it actually bugs out a little bit and will give us a incorrect kind of camera track and stuff like that. So let's go ahead and I want to open up a new project. So we're going to file, new, general. I'm not going to save that. Let's go up to plus and then VFX and motion tracking. Let's go ahead and open up our image sequence that we just created. So here's mine. I'm going to go ahead and open the clip there. And now we need to, of course, go back to the tracking settings. Since we're going to be tracking, we want to set these scene frames, prefetch our footage. Now you can see this blue bar down here is all blue. And basically that just means that it's going to take all of our frames of our actual video and puts it into our computer's RAM, just so it's a little bit easier to read in and read out. So now we have a little bit faster playback here. And then, of course, we will notice that everything is dull and gray again. If you remember, we have to go to the render properties down to color management, and instead of AGX, we wanted to set it to standard. Again, it doesn't automatically do that because that's just something that's automatically put with just the video editing workspace. So now that we have all of these settings correct, let's go ahead and talk about camera tracking. So over here, of course, there are three kind of settings I use 100% of the time, no matter what shot I'm doing. I talked about this a little bit in chapter 1, but just a refresher. We want to set match to previous frame. I just find that tracks everything a little bit nicer. Normalize will basically eliminate any exposure changes. And so say if the sun kind of comes out of a cloud and it gets our scene gets a little bit brighter, it's not going to, differently affect our tracking for that. And then over here we have these tracking settings extra. I'm going to put the correlation to a 0.9. Basically that just means that Blender has to be 90% sure that the tracker is correct for it to continue tracking that specific marker. So now we are actually ready to go ahead and set up some tracking markers. Now over here we have this motion model. Now 90% of the time I actually stick with just location. However, we have some other options there. Say if you were actually orbiting around an object, then you would actually maybe want some location and rotation and scale data. There, if I actually kind of view this scene, we can kind of figure out which motion model that we actually want to do. So we will notice I kind of move from side to side, so that's good. And then I actually move in a little bit. Now I could enable the scale, since some of the features would actually scale up in the scene. But since this is such a kind of slow moving track and stuff, I actually don't think that we need that scale data for Blender to actually get an accurate solve. Again, I stick to location 90% of the time. The other things are perspective and affine. Now these two things are kind of a way to kind of distort things. So if I actually go ahead and let's do perspective, say I tell it to go over here, we'll go ahead and Shift T to track this forward. You can see that the box right there is actually trying to distort based on the kind of plain wall right there. And so again, some people actually like using this to actually track that feature and stuff. I'm not a huge fan of it inside of Blender, since I find it does a little bit of artifacts sometimes for specific shots. And again, Blender is more of a kind of one size fits all program rather than a specific kind of use case scenario. And so for camera tracking specifically, I never really use the perspective and affine. Many people swear by it, and so you can definitely play around with those and get a result that you like. But for this specific tutorial, I'm going to be sticking with location. So now let's actually talk about the search size and pattern size again. So over here, these are the default values. If I actually go ahead and shift click, we'll add a point there. And then if I Alt S, we can reveal the search area. So this middle box is whatever we're going to be tracking. You can actually see this if we go to the track window over here. This is that box. Now the bigger box is the search size. Basically, if I we'll go to frame 1. Let me just go ahead and make a new marker there. So at frame 1, we'll go between frame 1 and 2. You can see that we're moving between those frames. Basically, this search size just has to be big enough to actually detect the movement. And so since this is a super slow moving camera, we actually don't need a super huge search size. So we can, of course, affect that. I'm just going to leave it as default since this is totally fine for our scene. But all you want to make sure is that this box in between frames is going to have whatever is in this little box inside. You just want to make sure that big box is big enough to detect that in the next frame over. And so that is all looking good. Let's go ahead and just delete everything like that. So now that we have kind of all of our settings defined, let's talk about some of the things that we have to watch out for actually manually camera tracking. So for this specific shot, this is kind of a best use case scenario because we have a ton of detail and patterns and stuff in this shot. We'll notice that we have a lot of rocks and pebbles on the ground, and so those are going to be great for us to actually use for camera tracking markers. So of course, the one thing that we want to watch out for is areas of high contrast, and so you can see like this point is perfect for that because it's basically a black dot on a white background, and so Blender is going to have a super easy time to actually pick that out of the crowd and go frame by frame and actually track that forward. Another thing that you can also do is patterns. And so say I come back here and we have like some unique patterns and stuff back here. We can actually use those patterns for Blender to go ahead and track. So say if I want to use this little kind of point down here, we can go ahead and use that as a point to actually track. And so that's going to give us a lot of detail to actually track forward. And so these are things that you'll pick up on. And, you know, when you're actually going out and looking at stuff, you'll kind of pick up in the real world environment and be like, oh, this would be a great area for camera tracking and stuff like that. What we can also do is we also want to have basically points in the foreground of our thing, and then we also want points away from the camera in the background. And so that is to do with a little thing called parallax. And so I explained it a little bit in the previous chapter, but basically you can think of parallax. If you're in a car, a moving car moving down the highway, and there's a mountain in the background, then that mountain to you is going to look like it's not moving at all. However, if you look to, maybe the ground right beside your car, you'll notice that a lot of the features like the grass and trees kind of closer to the car are blazing past you, moving super fast, and it's almost a blur to your eye. And that's because the closer you are to an object, the faster it is going to move compared to that thing. And so for us in that, specific example, our eyes were the camera. And so, of course, in this scene, the camera is the camera. And so I'll notice like objects over here, if we actually move throughout the scene, objects like this wall are going to be moving, a lot throughout our scene. However, if we kind of look in the background, kind of the trees and stuff back here, we'll notice that throughout our entire shot, they barely move at all. And so that's going to basically tell us a lot of parallax data and give us a lot of data for Blender to actually put some of these points into a 3D space. So I'll kind of explain that a little bit more as we go. But basically all we need to do is place trackers in the foreground and background of our thing so we have some separation so Blender can automatically tell that data. So again, this is kind of a great scene for that. I'm going to go ahead and just select some points that stand out to me. Now Blender only needs 8 points throughout the entire thing. However, I just like to use as many points that I can give Blender. The more the merrier, in my opinion, specifically for manually camera tracking. I'll show you a method in a little bit that'll take out a lot of this grunt and guesswork. That's going to be much better and is my method of choice for this. So let's go ahead and just tell some of these points again. I'll kind of explain my rationale. So like for this point right here, I'll notice there's a little like shadow under this rock, and so that shadow is very noticeable and very high contrast to the other areas around it. So that's where I'm going to go ahead and shift control click that just to select that point. So that is what I'm doing for all of these. I'm just kind of seeing areas of high contrast. It's going to give us some unique values so that Blender can actually use it for camera tracking. Now over here we can see that we have some in the background. Now this wall is actually closer to the camera, and so I want to select some of these points over here so that Blender can get some of that data as well. So let's just select some of those points, some of these, and then some of these. So that's looking good. Let's come over here as well, get some on this wall. Now I can be doing this all day. There are so many great points for this, so you really can't go wrong with this specific scene. That's why I tried to select kind of an easy scene for you guys to get started into camera tracking, just because there is so much detail in the scene that really any point, you could place it even in this white area and it'd probably track for this scene. So that is looking good. We'll place a little bit more points on this back wall here. Other thing to note is that we only want stationary objects in our scene. So of course all of these buildings aren't moving. However, these leaves in the background might actually be blowing in the wind. And so we actually don't want those leaves because then it would give us incorrect data since those leaves are actually physically moving and not stationary. So just very important to note there is we just want stationary kind of objects and stuff here. So that is looking pretty good. I might add just a little bit more detail over here, but once I add this last one, that'll be good. So now we basically have all these points. We have some, points in the foreground, so on the walls kind of closer to the camera, and then we have some points in the background, so, such as this wall in the background, which isn't moving as much as the foreground. So let's go ahead and track it. So the command to do that is Control T. So let's track that forward. So now you can see some made it to the end, and so that is looking good. Of course, now you can see what I'm talking about with parallax. So if I come down here, you can see some of the points. These are points that are on the ground closer to the camera, are actually moving a decent amount. You can see by the red and blue line right here that it is actually moving a decent amount. However, if we are on the same exact frame, some of these in the background, the red and blue line isn't as big, and so it's actually not moving as much. And so that's going to give Blender a lot of data to tell that these points back here are way further away from the camera than these points down here. And so that's how Blender is going to automatically kind of camera track that for us. So now that we have all this, let's go ahead and get a solve error. So over here in the solve tab, we need to set a and B keyframe. Now, of course, the A and B keyframe is going to be the range with the most amount of parallax. And so for me, if I'm looking through this clip, what I'll notice is that we actually start moving the camera forward. And so once we start moving the camera forward, you can see that areas that are closer to the camera, such as these areas over here, are actually moving much faster than these areas in the back. And so that's going to give us a lot of data to actually use to camera track. So if I notice, I'll notice around frame 80, I believe, is where the markers actually start moving forward, and then we'll go to like 140. So we'll do 80 to 140, just a nice range there. Now we can refine all of this stuff. If you actually did know your focal length, if you took your own footage, we can go ahead and set the focal length in the camera lens settings over here. That's that number. Of course, since I downloaded this footage online, I don't really know that number. So let's go ahead and just refine everything. These two numbers down here are the lens distortion. Now, every single camera lens has lens distortion. No matter how good the lens is, it's always going to have lens distortion. So, of course, we want Blender to automatically calculate that to give us the best result. So let's go ahead and solve our camera motion. And you can see that's gone through and given us a average solve error. And so solve error is basically the error that determines how good a track is. And so right now that 0.53 number basically means that we're about 0.5 of a pixel off. So let's zoom in really tight here. So right here, you can see this is about the size of a pixel. And so right now we're about half of a pixel off in terms of our solve. And so you can see that's almost negligible. Now, in my opinion, anything below a 0.3 is actually the goal for anything camera tracking that you're doing inside of Blender. So right now, 0.5 is actually a really decent first solve error, but we can get that number as low as possible. If I go ahead, I can manually do this. So let's go ahead and select A to select everything. Let's go to clip display, and then if we select this info tab, now we can see all this extra info data. Now if I kind of zoom in here, you can see that we have each track has a average solve error. So we can see here is a 0.17, and then down here we have a 0.11, a 0.27. So those are actually pretty decent solve error. If I come back out here, we'll try to select one that has a higher. You can see this one is super high. We have a 4.53. And so basically this solve error right here is the average of all of the tracks that we have. And so with this 4.53, it's actually bringing that number way up higher than we actually need it to be. So I can either come down here and automatically select that and delete that. What I actually like doing is coming into the cleanup section. We can go ahead and clean up tracks and bring this window down here. Then I basically just want to mess around with this reprojection error. So I'm going to bring this up, and we just want to kind of select the highest error tracks. And now you can see it's selecting some of those, higher tracks. So anything above a 0.77 right now is being selected. So these 4 markers up here. Let's just go ahead and delete those. So I'm going to go ahead and delete those tracks. And now you can see our number hasn't changed up here, and that's because we haven't resolved our camera motion. So anytime we make any changes to our our tracking scene, we need to go ahead and, of course, resolve our camera motion. So now that we have resolved and got some of those high error tracks out, now our average solve error is down lower. And so now we're at a 0.25. And so whereas before we were at, half a pixel average, now we are basically at a 1/4 of a pixel, error. And so that, again, is super, it's basically this small. And so that is actually really good, and we can get a super accurate kind of solve with that now. So let's go ahead and now we have everything set up. We can go ahead and set up the 3D tracking scene. So I'm going to go ahead and right click and join the areas. That window over there was just kind of a dope sheet. And so you can use that if you want. It just gives you some of the information of how long the trackers actually go and where the frame ranges are. Again, I never really use that since I can visually tell down here. So now we have this 3D scene. Let's go ahead and I want to set up background and set up the tracking scene. And now you can see it's added a bunch of settings over here. And so honestly, I don't really love all of these settings that it kind of defaultly picks. So we're going to change those in a little bit. But first of all, let's check out the 3D scene here. We can see that we have all of these tracking markers here. However, they're not correctly aligned. So I'll notice like some of these points down here, if you actually select the points up here, it'll select them down here. These points are on our floor. And so they should be on the floor plane of our 3D scene. However, they are not. They are actually just kind of floating in mid-space right here. So we actually have to define where the floor actually is. And so let's go ahead and come up here. Now I want to go ahead and place the floor manually. So what I'm going to do is I'm going to select 3 points. Blender basically needs 3 points to actually place objects onto our floor plane. So here are our 3 points up here. You can tell in the footage that's where they are. And so now let's go ahead and let's come down here. We can set up the floor orientation. So now that's basically rotated our scene. What I want to do before I do anything else is make sure our floor is correctly defined. And so that's very important for this scene. Let's come out to the layout view. I'm going to go ahead and hide this ground plane. So I'm going to hit H. And then we need to bring this cube up to the forefront. Now, if you remember from chapter 1, we were talking about this origin point. This origin point needs to remain on the ground plane at all times. And so in order to do that, let's hit Tab to go into edit mode. I'm going to hit A, then G to move around the object. Let's go in the Z direction just so we can move it up and down. Then I want to hold Control, and I want to snap it so that the origin point is right on the ground right now. So now if we go out of Tab by hitting Tab, we can size this, and it's always going to remain on our ground plane. Very important there. So now in order to actually test to make sure our ground is correctly set up, what I'm going to do is take a corner of our cube here, and then we can actually align it to one of the specs on the ground. So I'm going to hit G and then Shift Z to move it on every axis but the Z axis right there. And I'm basically just putting that point right on this little black dot here. So now if I move around the scene, in theory, we should have this black dot kind of remaining on the point at all times. And so you can see, within reason, it stays around that black point. It might be shifting around a little too much here, but again, that might be because the floor is actually a little bit bumpy or, not perfectly flat and stuff like that. So as I can see, it's actually sticking pretty well. This is where you want to go in your own scene and make sure your floor is sticking. So now that we have that, our floor plane is actually correctly defined and it's looking good. What we can do is go ahead and come back into motion tracking now. And let's go ahead and define some of the other things as well. So I'm going to set this point right here to be my origin. And then we want basically a point to define the rotation of our scene. So I'll notice this point down here is roughly along a axis of the rotation of our scene, of our wall down here. So I'm going to go ahead and set that to be our x-axis. So now it's basically rotated in our scene. So that is looking good. Now, of course, the biggest thing that we need to do is tell the correct scale of our scene. And so we have the scale button down here. The distance is in meters by default. And so whatever we need to do, we need to convert that to meters. And so basically, let's take a look at our point system down here. We basically need to tell two separate points and determine how far away are they from each other. And so we'll come here. I'll select kind of 2 points over here. So this point and this point. We'll say, since it's looking at the doorway, we'll say that is roughly 6 feet. And so 6 feet, we have to do that, convert that to meters. So 6 feet to meters. So over here, that's 1.8 meters. So of course, let's select those 2 points again. So these 2 points right here. And then let's set the scale. And then the distance down here, we just want to do a 1.8, like I said before. And now that's basically applied the correct scaling of our scene. Again, that's super important for any motion blur, for any depth of field, anything like that we do inside of Blender. It's going to be very important that we set the correct scale of our scene. So now let's bring it down. We can see that we're having this result and it looks much better. Let's actually go back out to the layout view. And now we can see that our ground plane is correctly set up. Our rotation is, somewhat nice so that, along this wall, it's actually being, transition along that wall pretty nice. So now we, have everything camera tracked and everything. Now what I want to do is I want to go ahead and set up the scene how I like to use it. Now, if you remember, Blender automatically set up a bunch of stuff over here. Now this gets a little bit too confusing for me, so I'm just going to go ahead and delete the foreground and background collections. And then I'll just delete everything besides our camera, like that. And then the background view layer it actually created. Now we want to be able to create our view layers as we need. And so sometimes I use view layers, sometimes I don't. So let's go ahead and delete this. And then the compositing section, these nodes up here are basically using to calculate our lens distortion. This gets a little bit more advanced into some visual effects inside of Blender. So for this beginner course, I'm not going to be dealing with lens distortion inside of Blender, so we can just delete these two nodes. And then also down here, the render layers node here was our background view layer. So since we just deleted that, we can delete both of these, alpha over and the render layers node here. And of course, we just want to plug the movie clip back into the alpha over saga ear, just so we have a super simple kind of compositing scene like this. The final thing that we need to do is in the layout section. What I like to do is select the camera, go up to the camera settings and background images. If you remember, we told Blender to set up our background image, which it automatically did. However, it goes ahead and tries to correct for lens distortion. And again, since I don't want to be dealing with any lens distortion, for example, if I was trying to model out this window, this wall, I actually want the unaltered footage in my view. And so what I can do is come down here. I want to check this render undistorted off. You can see if I turn that on and off, it's basically just adding that lens distortion on the side. So again, I want this to be unchecked. And the reason being is because if I ever need to model this out, I don't want to have to be dealing with the lens distortion view. I want to deal with the unaltered footage and how it actually look. Again, not going into lens distortion. However, if you are, I do highly recommend that you play around with this setting and get a result that you like. So now that we pretty much have the scene fully set up and ready to, place our CGI into it. So, whatever I do, say I want to add a mesh, we'll add a monkey to our scene. Whatever I want to do, I just want to remember that our ground plane is correctly defined. And so maybe we'll, move the monkey around. I might even come to the side view and we'll rotate her just so she's sitting on the floor right here. And so like that. She's basically on the floor, and now we can place her anywhere in kind of that floor plane, and she is correctly on that, and it's motion tracked and all that. And so that's everything of the first method of camera tracking. This is the very manual way to do everything. In the next way I'll show you is kind of my preferred method, which is actually getting Blender to do a lot of the heavy lifting. I find it gives you much more accurate results, and also it speeds up your workflow a lot. So let's go ahead and get started into that. So let's go ahead, File, Open New, General. I'm going to save that. And then, of course, we need to open up VFX Motion Tracking. Now let's open up that image sequence. So again, you do want to convert your video into an image sequence. I believe this one is frame 1 to 150 if you do want to copy my exact settings. So let's go ahead and hit A, select everything, and open the clip. Of course, like everything, we have to come up here and set these scene frames and prefetch our footage, and also set our color management back to standard. So of course we do want to set up those settings that we use no matter what camera tracking we are doing, which is match previous frame, normalize, and then tracking settings extra to a 0.9. So again, those are just all of my preferred settings for any type of motion track. So now what we can do, we can see this is a drone shot of, I believe, downtown Los Angeles. And basically we have a road that we want to place some type of CGI on. And so what we can do, we can, of course, go, control click, add markers, all that stuff. What I want to do is I want Blender to go ahead and detect all of the markers and go ahead and track it for us. So let's go ahead and do that. So first of all, the motion model, of course, I'm going to be using location just because this specific method, location is going to be the best. I find in 80% of the videos I use, and the other 20%, most times I'm going to be sticking on location and scale. But of course, location is fine for this shot. So let's go ahead. There's this detect features button up here. I am on frame 1. And so let's go ahead and press detect features. Now we can see that it's basically getting Blender to automatically detect some of the high contrast points that we were manually doing before. And so it does a pretty nice job. Now in this method, we want as many tracking markers as we possibly can handle. So let's come down to detect features. And the idea here is that we want to decrease the threshold just so that Blender will get literally any single point that it deems is maybe possible for camera tracking. And so we have all of the thresholds down here. And then we can also decrease the distance in between the points. So right now it's on 120, we can set it to 80. And now we actually have more points into the scene. So of course you can play around with that number as well. I might actually go ahead and set it down to 60 just so we have a ton of tracking markers in our scene. So now we have a ton. Again, that is on frame 1. So I'm going to go ahead and Control T to track those all forward. And now you can see they're all going haywire. We have a lot of missing trackers, all that stuff. So don't worry about that now. This is kind of a brute force type method. So now we have a set of markers at the beginning of our footage, and so that's looking good. What I want to do is I want to go to the exact end of our footage. So for me, again, that's frame 150. So at the end of the footage, I now want a new set of markers. So let's go ahead and detect features again. I can save all of these same exact settings. And what I want to do is I now want to track these backwards. And so the command shortcut for that is Control, Shift, and then T to track those backwards. Now you can see that we basically have a kind of cutout section right here for all of those tracking markers. So now we have a section at the beginning, and then we have a section at the end of our footage. Now let's go to the middle of our footage, since we also want one in the middle. Again, this is just trying to get as many tracking markers as possible, and then we can slowly whittle our way down until we get just the most accurate tracking markers. So let's go ahead and detect features one more time, and Control T to track those forward. I'm going to come back to frame 80, and then Control Shift T to track those backwards. Now for this specific video, I only need 3 sets of markers. So again, that's one at frame 1, one at frame 150, and then one at frame 80. Now in your specific video, if you're doing other videos, you might need more sets of markers, like 4 or 5, depending on how many markers there are throughout your footage and how fast your camera motion actually moves. So now you can see that we have a bunch of markers in our scene. Now, if we view the graph section down here, this graph section is basically just a visual kind of view of all the markers in our scene. We can see that it is a lot. And if we kind of view up here, you'll notice that a lot of our markers are kind of going all over the place. And so this is where we want to do a manual pass to delete as many bad tracking markers as possible. So if I come up here, we'll do a visual pass first. So if I scrub through our footage, you'll notice that a lot of markers are moving on their own. And so if you remember, we only want kind of markers to be attached to stationary objects. So down here, we have this car in our scene. You can see that we have some markers actually moving along with our car. And so we don't want that. We want to go ahead and try to delete all of those markers that it's attached to with our car. So I'm actually going to hit C, and that'll bring this up. If I click and then drag, we can actually select multiple markers at once. So let's just delete all of these markers that are attached to the car. Now we have some problems up here with some of the power lines. Now the power lines are, a little bit crazy. If I was actually manual with camera tracking, I actually wouldn't put any of the markers on the power lines just for my personal preference. So let's just go ahead and delete some of the ones that are going a little bit haywire like that. And then let's just scroll through our footage. We'll notice that some more are kind of on the power lines going crazy like that. We'll zoom down here. There are some ones that are going a little crazy down there. You can also see the lines. If any lines kind of stand out to you, you can just go ahead and delete those as well. So that looks pretty decent. There are a lot of ones moving over here with the train tracks, and so we can just go ahead and delete this entire section over here. So that's looking pretty good, pretty good visual pass. Now let's go down to the graph section. Now the graph section, again, is kind of a visual way to look at all of your tracking markers. And so all you need to know is we need to basically select all of the outliers for our graph section. And so you'll notice that there are some green kind of spikes here. So let's go ahead and delete some of the green spikes and also the red spikes. We basically want any kind of spikes or anything that's out of the ordinary to go ahead and just delete those and get those out of the way. And so it's actually very easy for this scene to tell where all these spike sections are, since, again, they are very large spikes to be able to tell. Now, up here, it's a little bit different. Let's go ahead and select some of the, more noticeable spikes. But in here, we can see that we have some green spikes, but not red spikes. Now, basically, red and green is X and Y on the axes up here. And so, again, you do want to be looking for both of those axes. So there are some green kind of weird spikes in here. And then there's a whole mess over here, so we can just delete a bunch of these spikes in here. You may have to zoom in a little bit to delete some of these green spikes in here as well. And so now that's pretty much gotten 90% of the kind of outliers out. We can go ahead and let Blender kind of automatically detect some of the other outliers and get those out as well. So let's go ahead and get our first solve. So I'm going to come over to the Solve tab. Of course, we do have to select our A and B keyframe. So with the for this specific scene, I believe we'll just do 40 to 80 because you can't really go wrong for this scene since it's such a staple move. So 40 to 80 is what I'll select there. Of course, I want to refine everything and go ahead and solve our camera motion. Okay, so now you can see we got our first solve error of a 4.78. So that's much bigger, of course. We do want to get that as low as possible. And so again, this method will always provide you with a larger solve error to begin with. However, we can whittle that down lower and lower as we go. So let's go ahead and do our cleanup. So let's clean track over here. And basically with this method, what we're going to do is we're going to select the highest error tracks. We're going to delete those and then resolve our camera motion and get our solve error lower and lower. So let's go and do that. I'm going to push this number up until we're just selecting a few. So somewhere like 5.2 for me, I'm going to go ahead and delete all of these high error tracks. And then let's solve the camera motion. And again, since this number is a average, it's basically gotten our solve error average down upon the whole scene. And so now we're at a 1.15. So let's go ahead and do that a couple more times. So clean tracks, reprojection error all the way up. So we're just selecting some of the highest ones. Let's delete those and then resolve our camera motion again. Now you can see we're down to a 0.5, and so that's just a really great method to kind of whittle it down. Again, we do want to kind of do this slowly because if you actually go and say we want to clean tracks and do almost all of them and stuff, we're going to be selecting some potentially good tracks that are going to be kind of calculated with our solve error and stuff like that. And so that's why you don't want to select a lot of tracks. You only want to select kind of the top 10% of tracks, in my opinion. So let's go ahead and delete those and solve the camera motion again. That way we can slowly whittle it down, so we make sure that we only delete the super bad tracks. So again, just going to do one or two more kind of passes of this, try to get this below a 0.3. So we're at that. Let's just do one more because I think we can get a little bit more data in here. Another thing for this method is you don't want to delete too many tracks. If you delete too many tracks, then what you'll find is that your solve error will shoot all the way up and give you something like 80 or 100 plus pixel solve error. And so this scene is great because we have a lot of tracking markers still. So let's solve it one last time, see what number we get. Okay, so we got a 0.22. That's actually really good, and will give us a super accurate solve. So again, we do have a lot of data here, a lot of markers. So I'm not worried about it being a inaccurate solve because we have so much information here. The other important thing for this specific track is down here. It might be hard to see on video, but there's actually this blue line right here. And so this blue line represents the solve error line throughout the entire footage. Now, the very important thing about that is that you always want to double check that that blue line is perfectly flat. Basically, perfectly flat is going to mean that this 0.22 number is going to be throughout the entire footage. What you might find sometimes is that at the beginning, it might give you a low solve error, like a 0.2 or something like that. But at the end, it'll jump up and jitter around and stuff. And basically, even though that you got a low solve error, that'll mean that the average is low enough here, but you might have like some jumping and some jittering down here. So you always want to make sure that that blue line is as flat as possible, which mine is. Mine is perfectly flat, and so that is all good. Now let's go ahead and orientate everything and get our 3D scene set up. So let's set up our background and tracking scene. Of course, like before, everything is not aligned up here. So you can see that we have to align our floor plane. And so let's go ahead and do that. I'm going to come down here. This floor plan is actually pretty nice since we have a lot of markers on our floor. So I'm just going to select 3 points. So we'll select this one, and this one right here, and select that to be our floor plane. Now we can see that is correctly selected up here. Let's go ahead and define the scale. Now, if I think about kind of a lane inside of the US, each lane is about 10 feet long. And so we can select 2 points down here. So this point and this point, we'll say that's roughly around like 10 feet in length. And so let's do 10 feet to meters is about 0.3 meter, or sorry, 3 meters. So we'll go and put that. So again, we'll select these 2 points, and for scale down here, we'll set that to be we'll set that to be 3 meters. So now that's the correct scale of our scene. Let's go ahead and also determine the origin and rotation. So I'm going to set this to be our origin point. And then since it's along the same line here, I can set this to be our x-axis. So now we have all of the things kind of defined and our 3D scene set up. Let's come out to the layout tab. Before I do anything, I do want to undo all of the stuff that Blender did. So delete the foreground and background collection. Then we can delete these 4 objects and go ahead and delete the background. Go to compositing, delete these 4 nodes since we're not going to deal with the compositing of the actual lens distortion. Then we can plug the movie clip into the alpha over. And then finally, the final thing that we always need to do is go into the camera, the background images, and turn render undistorted off because of the lens distortion. We don't want to have to worry about. So let's go ahead and I want to Shift A. I want to do our cube test. If you remember, let's go ahead and go into the tab, G, Z, Control, shift that up 1 unit. And now the ground point our origin point is on the ground. So if we go in S to scale this out now, let's just set this cube on the bottom and make sure it sticks to the ground, which it does. We can even get more advanced into it. There's this little black dot here, so I'll set the corner to our black dot. And now if we move throughout our clip, we should notice that our corner never moves from that black dot. So that is looking good, and our camera track is correct, and we are ready to set up the CGI. Now, of course, this is where you would be going into CGI and compositing all that stuff. Again, for this chapter, I'm just going to be dealing with the actual camera tracking and not the actual thing. We'll get more into, that kind of side of things in chapter 4, where we actually get really involved and do a complete shot from scratch. So let's go ahead and do one more example, kind of speed through this last one so we can test to make sure that this method does work. So let's go File, New, General. I'm going to go to Plus, VFX, Motion Tracking, and open up our last kind of movie sequence. So here's my last image sequence. Again, 1 to 200 if you do want to copy along. Let's hit A to open the clip, and then we need to set the scene frames prefetch, and then let's set our view transform to standard. So now let's do the same exact process. So again, match to previous frame, normalize, and then tracking settings extra. Set the correlation to a 0.9. Now this thing, I'll notice that our motion model is going to be fine with location. Again, I'm determining that because I'm determining the camera motion. And so since we're only moving forward, it's, location is totally fine. If we were moving around the scene, that's maybe where I would consider doing perspective and affine. But again, this is kind of just a smooth dolly forward. And so we don't have to worry about that. So let's go ahead and detect some features. So let's set this down to a 0.01, and then distance will go to an 80. We'll go to a 60 now. So that looks pretty good. Let's go and Control T, track those forward. Now we're at the very end. Let's detect some more features. Control Shift T, track those backwards. Then we'll come to frame 100, detect features, Control T to track those forward. Go back to 100 and Control Shift T to track those backwards. Now let's just kind of do a visual pass to make sure that none of them are moving around. And so that looks pretty good. I don't really notice anybody visually that's moving around. Let's come back down here. I do notice a little bit of spike, so let's go to this kind of thing right here. So you can see with this spike right here, we can see this one is actually zooming around the scene, and so that's kind of a way to view it on the graph and view it up here as well, just to see that what the graph is actually doing. So let's go ahead and delete that. We'll delete some of these other spikes as well, just in case those are going a little bit haywire. But everything else, maybe some of these down here, but everything else looks pretty within reason. So now let's bring this down here. We can go ahead and go into the Solve tab. Now let's see. I do like that there are some points in the foreground right here. So what I'm going to do is I'll set it to like frame, we'll do like 70 to like 110. So 70 to 110, again, that's just the area of most parallax. And so we have a lot of markers in this area, but a lot of markers in the background. So I just want a frame range that kind of mimics that. So let's refine everything and go ahead and solve our camera motion. Okay, so we got a solve error of 1.22. Let's go ahead and get that lower. So I'm going to go ahead and clean tracks. We're going to push this reprojection error up, delete those, solve camera motion again. And now we got a 0.44. So that's really good. Let's go ahead and get that lower still. So clean tracks again. Just going to select some of those higher ones there and then delete those. Again, I'm kind of just looking down here and I notice that we still have a lot, so I can push it a little bit more. We can push it and clean the tracks a little bit more. Again, technically Blender only needs 8 tracks at a time. So of course I don't want to push it all the way down to 8. I want as many as I can get away with. But if you ever are in that kind of case scenario, you can always push it a little bit lower. So let's go one more, because I think we can still have a lot of data here to work with. So there we go. So we have a 0.24, so that's actually really nice and will give us a really good track. So let's go ahead and set up this scene. So set background, set up tracking scene. We need to, of course, define a floor plane. Now I believe there's a little bit of like a ramp here or something. I'm not totally sure, but let's just go ahead and select like these 3 points here. I'm going to select this to be our floor, which that looks fine. I might actually select 3 different points because you'll notice up here it's a little bit tilted. So that just tells me I need to select some different points here. So we'll maybe select this point, and this point right here. Set that. There we go. Now it's a little bit more accurate. So now let's of course define a scale. Now let's see. I think like this point and this point, this is probably roughly like 8 feet. So we'll do like 8 feet 2 meters. So 2.4. So we'll set these 2 points to be 2.4. Let's do the rotation now. So I'm going to set this to be our origin, and then this to be our x-axis. So now with all that set up, we do, of course, have to test our floor to make sure it's as accurate as possible. Let's go ahead and delete some of this stuff. Just going to delete all this. So we just have the camera background we can delete, compositing up here, and delete these 4 nodes, plug the movie clip into the alpha over, and then in the layout section, I just want to do my cube test. So add a cube, tab, G, Z, control, shift that up 1, then S to scale that down. And let's find a feature on the floor. So like this little, there's a little black dot there. So now let's just play around our scene. And now you can see that our corner of our kind of cube perfectly tracks to that little edge right there. So now we know that our scene is correctly tracked. And if I play this, you can see it's, you know, perfectly on the thing. What I do have to, of course, do is let's go ahead and turn the lens distortion off. And so now that is pretty much it. You can see that we got a super fast camera track, you know, let Blender do all of the heavy lifting, and this is, you know, perfectly fine for most of the visual effects that I'm going to be using for. Of course, if I was doing this for a client, or if I needed it to be super precise, I'd probably marry the two, you know, methods of go ahead and try to let Blender do as much as possible, but then do a kind of manual track at the end to make sure that everything lines up and is as accurate as possible. And so now you can see that we have a super good result, super fast and super easy like that. So hopefully you guys learned a thing or two about camera tracking and all the methods that we can do to camera track inside of Blender, and all of the things that you have to keep into account, because camera tracking is a very particular thing. And so if you take anything away from this chapter, I want you to remember that we need objects closer to the camera. And so we need foreground tracking markers, and then we also need tracking markers in the background, because that's going to lead us to the you know, the best tracking results. If I actually increase the opacity here, the reason this scene works so well, again, is because we kind of have like some fences here. We have some like lettering and stuff, and this paper over here. All of that stuff is closer to the camera, and then we also have a super large depth in this hallway here. So we have some lights and stuff in the background that A, don't move that much, and B, are much further away from the camera, so that we can actually get that accurate information and give Blender and give a accurate camera track scene. And so hopefully you like that. In the next chapter, we're going to be talking about planar tracking and some of the amazing stuff that you can do there. I'm super excited about that chapter. There's some really cool stuff inside of Blender that, you know, is quick and easy and will give you amazing results. And so thanks so much for watching, and I will see you in chapter 3.